Now this is also an easy one. So if you look at it, A, B, C, D are large conducting plates kept parallel to each other, and A and D are fixed, B and C can be movable. Okay. So but they are connecting by rigid rod, conducting rod. In a conducting rod, just you need to consider that it is a this is like a connecting wire. So but it is movable. So initially the distance between the plates A and B is the same as the between C and D. Okay, so let us take the distance between A and B, and C and D is D. So what is that? This arrangement I can write it as what? In a simple way I can write it this way. So the distance is G and D. Okay, since the parallel plates, large conducting, kept parallel to each other, and is there anything they have given? No, we are assuming that the area is same. Okay, because they have not given anything other than this one. Only they talk about the distance. We just think that the area and the plates are that medium, everything is same. So in that case, what is C1 ma? C1 is epsilon naught A by D. C2 is epsilon naught A by D. Okay. So here, since the distance is same, D will be there. Okay. So what is net effective capacitance? Since both of them are in series, so series combination C effective will be equal to 1 by C effective is 1 by C1 plus 1 by C2. So which is nothing but, okay, D by epsilon naught A, reciprocal of that, D by epsilon naught A divided by 1 by C effective. So 1 by C effective will be equal to epsilon naught A. If you take it as LCM, it is 2D. So this leads to what? C effective is epsilon naught A by D, 2D. Okay, so this is the effective capacitance. But what they say now, read the question carefully. So here, initially the distance between the same. But if now the rod along with the plates B and C is slightly moved towards right, the capacitance, what will happen to the capacitance at 1 and 2, they are asking. So what we are basically doing, we are shifting it. Okay, if this is the plate A, we are shifting the plate B towards the right along with the C and this rod. Okay, so everything will be moved, okay, towards right. But you remember that A and D are fixed. You cannot move further beyond this. Okay, so this distance is fixed. Only this distance between the plates will be increased or decreased since we are moving towards right. Okay, so between A and B the distance have increased. Let us say X is the distance through which it is moved. Okay, X is the distance through which it is moved. So between the A and B, already what is that? My A and B, already the distance is D. Now since we moved through X distance, so D plus X. But at the same time, since A to D it is a fixed distance, what will happen? Between C and D it will decrease. So it is D minus X the distance will be. Now I can do what? I can just find this effective capacitance on series combination. So C1 will be equal to what? C1 is now epsilon naught A divided by distance between them is D plus X. C2 is epsilon naught A divided by D minus X, because correspondingly the distance is reduced there. So 1 by C effective will be equal to what? It is equal to epsilon naught A by D plus X. 1 by C1 plus 1 by C2. Be careful, okay, in that. So it is nothing but reciprocal of it is D plus X by epsilon naught A plus D minus X by epsilon naught A. So this will give me what? C effective. 1 by C effective will be equal to epsilon naught A common. So it is D plus X plus D minus X cancels 2D by epsilon naught A. This leads to what? C effective is epsilon naught A by 2D. Compare the equation. Sorry for the little messy work. Okay. So here compare equation 1 and 2. You got the same. So nothing happened between them. So it is remaining unchanged. The answer is remains unchanged.